Hi. So in this video we are going to talk about the next insertion operation, insert at a given position in a list which is implemented using arrays. The implementation will be in C. First let us discuss the algorithm for the operation. What is the first step? You will check whether the list is full. This is the usual operation that we do for all the insert operations. You check if the list is full, or if here one more thing we have to check, if the position is valid or not. What is meant by validity of the position is, for example, if there are 3 elements, right, I can tell that insert at a position 1. See, I am going to when I want to do insert at a given position, I am going to tell the position as a human, right. So I will tell insert at position 1 means it should be placed at the index 0. When I tell insert at the position 2, it should be placed at the index 1, like that. Okay. So if there are 3 elements, I can tell insert at the position 3 or 4. 4 can also be valid, right. It will be placed after the 3 elements. I cannot tell that insert at the position 5 or 6 or something like that, because that cannot be allowed in this particular operation. In insert position, either it can be intermediate positions or at the end of the existing elements, right. So we check the validity of the position. If the position is not valid or if the list is full, then this function is going to return false. And next thing is, if the list is empty and position is 1, right. If the list is empty and position is 1, then you can place the element as the first element and increment the number of elements in the list, and you can return true. Otherwise, what you have to do? You have to create an empty space in the given position of the list. For example, if the function is called with position as 3, then you must make the third space to be free, and then you have to place the element there. So you will be you will be shifting all elements from the end of the list right by one place. This is similar to what we did in insert beginning. The only change that we will be doing is, in insert beginning we will start from the last element and we will come till the first element. But here we are going to start from the last element and we will come till position -1. Till that we will be moving, and then we will place. Let me show with the analogy. So for example, if I want to insert a new element at position 2, right. If I tell position 2, I want to make an insertion. So I want to replace this particular element, right. And the algorithm tells you have to start from the last and you have to go till this particular element. My human indexing is position 2, but look at the indexing that is being followed by the system. It will be 0, 1, isn't it? So when I write the logical code, I have to mention that I have to move elements till position -1, right. And then this particular chair will be free. I can place the new element here, right. This is the idea behind the implementation. Now let us look at the complexity of the algorithm. How can we write the complexity of the algorithm? Whether it is constant? No, definitely no. It depends on the number of elements already in the list, right, and how it is dependent. For example, if there are 10 people already inside the room, right, let us just compare it with the analogy. And if a new person is coming and he has to occupy seat number 3, then 7 people has to shift, isn't it? So 10 means 7, right. Like this we can get some relationship. If one person takes 1 second to shift his space, then 7 people will take 7 seconds and so on, right. But anyway, it depends on 2 things. One is the number of elements in the array, or if you take the real time example, number of people sitting in the chair, and other one is the position where we have to insert, right. And the worst case is position is 1. When I want to insert at the position 1, that is also allowed, right. So the complexity can be told, it depends on the number of elements, so it can be big O of n. This is a rough idea of complexity for insert at a given position. Now let us try to implement the code for this particular operation and see. So return type, actually it should be boolean. Since there is no bool data type in C language, we are giving the return type as int. And let us write the insert position function. Actually, insert position, generally insert operations take two things, should know two things. One is the list in which insertion has to happen, and next one is the element which should be inserted. But here three things are required. One is the list in which the insert operation has to happen, and next one is the position in which it has to happen, and the third one is the element that should be inserted. So these are all the parameters. So three arguments should be passed, and once again just recall that we have to pass it by address. Why address? Because the changes whatever we make in the function should be reflected in the main also. So it should be passed by address only. I am not going to return the list, so it should be passed by address only. Okay. Now what should we do then? I need to iterate through, so let me have a I, and then first is validity checking. How first condition of that is whether the list is full. You have to check whether the list is full, right? If the list is full, then you are going to return false, or what the condition comes. Next condition is about the position. If the position is less than or equal to 0, since I told that human indexing is going to be done, so my position cannot be 0 also. Position starts from 1 only, so position less than or equal to 0, and similarly position greater than number of elements in the list. Okay. Maximum it can be equal to number of elements. If there are 3 elements, then you can tell the position, okay, number of, if there are 3 elements, then you will tell up to 4, that can be 2. Yes, I think it's fine. It can be up to number of elements plus 1. Okay. So if the position is greater than number of elements plus 1, then you are going to return 0, right? That's what we are going to do. Otherwise, you come here, and now we are going to start moving through. So number of elements minus 1, right? That will be the location of the last element, and greater than or equal to POS minus 1, right? And I minus minus. Since we are moving from the end to the beginning, I minus minus, right? And we are going to do the shift till position minus 1, because that is the place where we are going to place the new element. What we are going to do? We are going to just shift the elements. So L elements of I plus 1 is equal to L elements of I, right? So all the elements will be shifted right, and then we are going to place the, okay, this should be inside for loop, and this next line is outside the for loop, right? So elements of position minus 1, right? Because according to the indexing followed by the system, it should be position minus 1. If I want it to be the third element, I have to place it at the index 2, right? Equal to x. This is what I will be doing, and also I should remember to update the number of elements in the list, and then tell return 1. Okay. So this is what we are going to do for insert at a position, and I am going to uncomment this code. Here already I am checking insert position. Okay. So let us see the code, how it will work. So a new list is created. First of all, you are getting n. N indicates the number of elements, that is the number of maximum number of elements that can be accommodated inside the list. That is the capacity of the list. You are reading from the user, right? And let us assume that first you are giving the capacity as 3, okay? And you are creating a list where you can place 3 elements. First you are insert beginning 3, right? And insert end 2, right? So 2 will be here, and then you are telling insert beginning 1, right? 1, 3, 2 will be the elements, and then you are trying to insert position and you are telling 2, 10. Actually 2 comma 10 it has become full. So next case is when you have 4 as the capacity, you will be having this. Now this line will come. You are trying to insert as the second element, right? 10. Okay. So it should be inserted here, and you are trying to now insert it again. That will not happen, right? And when you print, it should print 1, 10, 3, 2. This is what is expected, and it should also print insertion failed. Okay, that should happen. Let us try to compile the code and check. Yeah, there is. Okay, let us check this line. Equal to. There is equal to. Is missing. So I will give first 4. Since it is 4, what you can see is first it is printing insertion failed. This is the end, trying to print. 4 is the capacity. Already 4 elements are inserted, isn't it? So you get that message. And now look at the output. Yeah, 4 elements. 4 is the capacity. 1, 10, 3, 2. 1, 10, 3, 2 we have got, and insert failed is due to the 5th element which we try to insert. Now let us run again and give the capacity is 5. Then now you will see 1, 10, 3, 2, 4, right? Because the 4th element 4 is added as the last element. Capacity I have given as 5, right? So as usual, the code will be shared in GitHub and the link will be provided. You can check the code and learn it. You can change the cases and also check if the position. Okay, I will show one more thing. Like if I am trying to insert as the 10th one, what should happen? Let us see. Let me give the capacity as 5. You can see that it is printing insert position failed, right? It cannot insert as the 10th element because there are only already 3 elements. So it can be only up to if there are 3 elements, I can give as 4th element, right? So 10 has become the 4th element. You can try out all the options and see. Thank you.